Hey there.
How's it going?
It's going. How are you?
I'm all right. Not
Uh-oh.
too bad.
Did you end up doing okay on that homework?
Yeah, I did. Thank you so much. You
Good.
saved my life.
Oh, you're so nice.
Saved
How'd
my
you,
life.
how'd you do with this one?
I did okay, but I'm having troubles getting back onto it. My internet's being kind of wacky, so
Uh-oh.
crossing my fingers for tonight that everything goes smooth.
Right?
How about you?
That was fine. The
Yeah,
only thing I have to remember is the significance level. We don't divide it on this one. So that's the main difference that I saw.
right. Yeah. I feel like I do okay as long as I like go back and follow the videos and
Yeah.
see how to do everything.
I'm nervous about the test because I have no idea what she's gonna have it be like, but I guess we'll figure
I
it out.
know. I know. See how close it is to the review.
Yeah. And you just never know
Well,
what you're actually gonna need from that.
I know. I know. Well, should we get started on the quiz, or is there anything you want to go over for
No,
the?
I'm good if you are.
I feel like I'm good. I mean, I'm maybe naive to think that, but we'll see.
We'll see. All right. So 1, 2. Yeah, we did. Okay. You ready?
Yep.
In an ANOVA hypothesis test, we reject the null when there is sufficient evidence to indicate that at least one mean is different from the others. True.
True.
Do you
Yep.
agree?
Yep. I just read that, so
What requirements need to be checked when performing an ANOVA hypothesis test? Sample means are all positive. Data in each group are normally distributed. Variances are equal in each group. None of the above.
hmm.
I think it might be B and C
Yeah, I just had my notes up, so I'm trying to see if I can.
because he said that to us. I don't think I wrote it down. Hang on. Okay. ANOVA requirements. The samples are from simple random sampling. The samples are independent. The populations have the same variances, and the data are normally distributed for each group.
So B and C.
So B and C.
Yeah.
Deja, get away from my computer. Crazy girl.
This-
All right. So check if each group is normally distributed. Do the following. QQ plot, right?
Yeah. Yeah.
Okay. We assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. I think it's that one. Let me look back at my notes. The populations have the same variances. Check if the largest, nope, it's 2 times. Check if the largest standard deviation is no more than 2 times the smallest standard deviation.
Okay.
So I think that, well,
C.
that doesn't say standard deviation. That says sample mean.
Sample. Let me see if I can't find it on the notes right quick. Sample.
Variance is checking requirements. Sample size. Let me know if you find anything. I'm going to try to open the textbook and see what it says.
Yeah, that's where I'm looking at right now is the textbook. Let me get a question again.
Did you eat all the vegetables? I didn't eat all of them. Then did you put them away? You can have 5.
Yes. I think it's the 4 times the smallest variance.
Is that right? Okay.
Yeah. It says the variances are equal for each group. This requirement is checked by examining the variances. The rule we will use is if the largest variance is less than or equal to 4 times the smallest variance.
So I did hear that somewhere. Alrighty.
Yeah.
An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? 4? No. 2-sample t-test between every 2 pairs of samples.
If
Two independents between every pair. One, two. That seems too easy to say 4.
I know that I can't think of anything other than 4 as well. Let me see.
Let me see. I want to look in the book for a second. I remember him talking about it, and I didn't really read all of the chapter yet. So
Let's see.
are you really chomping in my ear, Deja? F distribution requirements. Love you. Good night. Okay. Well, you need to get to sleep. It's late. Okay, let me see. What's this say?
I'm not even seeing anything in the notes on it.
Yeah, I don't remember even hearing that. But you can come give me a hug, but I'm not talking to you about what Deja's eating. I'm on my meeting right now. Go to bed. I love you. Doesn't even really break. Okay, let's see. Learning outcomes say anything? No. All right, let's get that one and
Yeah.
keep going, and then we'll see if we get an impression on it later. Maybe we should start these meetings with a prayer.
Seriously.
Okay, the soccer shoes data has 6 groups. This data can be found on the wiki. Load all 6 samples into the quantitative inference procedure spreadsheet or perform an ANOVA test and observe that the p-value is 0.0809. Remove the SOX data. What is the p-value? Okay, so we need to go to SPSS.
Yeah. 221.
Soccer shoes. Okay. Okay. So
Alright.
too many papers out. Let's see. Okay, so I'm just going to do everything that he did because I think we'll have to go back and reference it anyway.
Yeah.
I don't know. It's saying we just need 6 groups. These data can be found in the wiki. Load all 6 or perform an ANOVA test to observe 0.0809. So I guess we'll just do the ANOVA test to start with. So that's first we need to recode it, right? Because the SOX doesn't have a number. So
Yeah.
I'm going to transform automatic recode. And we want to recode footwear. Footwear code. New name. Okay. Okay. Then analyze, compare means, one-way ANOVA, footwear recode. Is the factor. Options. Okay, let's see if I get what she had. She said 0.0809 was the p-value. 0.08. I don't get 0.0809, but I got 0.081. Is that what you got?
I'm not there yet because my computer is just, everything is
Slow.
loading super slow right now. Yeah.
I guess it would round to 0.081, so I guess so.
Yeah, that'd probably work.
Okay, and then it says take out the SOX data. So how do we do that?
I got this.
We don't want that group. You just take it out of SPSS?
I guess so. Let me
I don't
see
think we've
what the
ever done that
directions
before.
say.
Remove the SOX data. What is the p-value? I guess we can just delete those cells. So with only the 4 groups, I got 0.309.
0.309?
Mm-hmm.
Okay, give me a minute. Okay, yeah, that's what I got.
Okay, so 0.30. Does it have a 0 in front of it?
I
No.
don't think it matters.
No, it doesn't. Okay. The p-value always goes up when only one group is removed compared to the p-value when all 6 samples are included. The p-value always goes up when only one group is removed. We didn't talk about removing groups. Is that in the lesson, the textbook?
The lesson was actually pretty short reading it.
So were
And I
the
don't remember.
videos. I don't remember.
Yeah, I don't
talking
remember
about-
even reading that. Let's see. P-value.
I'll go back and look at it again.
Seriously. Yeah, I'm not seeing anything about that.
Yeah. Me either. Isn't that weird?
Yes.
I don't see. I mean, the lesson really follows the videos completely. There's nothing additional in there. Nothing
Right.
about removing a group. Maybe it's a logic thing we just need to try to figure out. Where's the beginning of this?
See.
I mean, it just doesn't really talk about p-values like that.
P-value always goes up when one group is removed.
So probability, the probability of something happening go up if you remove a group? Not necessarily. I don't know.
I hate true and false questions.
Well, even the next one says, what is the highest p-value you see when removing only one group? When all 6 samples are used, what's the minimum smallest variance? Like, I don't.
Let me see.
So this must still be all off the soccer shoes data.
Yeah, I was just going back to that. I was gonna say.
So maybe
when
we should put
go
socks
back
back and take something else out?
or just see. Yeah, that
Oh no.
I don't know either.
Kind of stumped on that. That's strange.
Let's see. So when all 6. So what was the p-value with all 6 groups?
0.081.
0.081.
Mm-hmm.
And then when we removed the socks, the p-value is 0.309.
Mm-hmm.
So I guess in this case it'd be true, right? Because the p-value always goes up
Yeah, but
when
always
only.
is such a definite word.
I know. I wish it would say if it was asking about if it compared it to this question or not. But it seems like it does. I don't know.
I think I want to try taking something else out
Okay, that
and
works for
just see
me.
what it does. Then I have to pull the data again because I deleted that socks data already from that one. Okay. So if I recode the footwear, okay, and so what if we take out all of A, whatever A is?
That works.
Let's see what that does to our p-value. Compare means, one-way ANOVA. See, that one's 0.060. That's still up though from, no, that's down from 0.081. So that's false. You think?
Yeah, I don't know. That
I
works
don't
for
know.
me. I don't know. I feel like I could go both ways, so I'm good with going false.
The whole thing throws me off now because it wasn't discussed in the lesson.
I know.
Okay, what is the highest p-value you see when removing only one group? You will need to compute an ANOVA for each possible option.
Okay.
So we need to do one removing everything? Like one at a time? We need to do one for each group?
Let me see. So how do you compute an ANOVA? Analyze. Compare means.
Is that what you get from that? Is we need to do it removing each
This
group?
it kind of seems like that's what we need to do, huh?
Because we have 3 of them already. We have all 6, we have minus socks, and we have minus A so far. So I guess we can take B out now and see what our p-value is.
Yeah.
Kind of weird. B. Okay. So without B, I got 0.052.
Okay. I think highest p-value. That's pretty tedious having to take out each one, huh?
Yeah. You would think we must be missing something.
Yeah, I'm trying to look through what we did earlier. Let's check your requirements. Do the following. Yeah, no, do we?
Let me know if you found anything. I'm just going to go through and take each one of them out.
Oh
and see what
no,
we get.
no, I think you're on a better track than me. I'm just trying to go back through the notes and do it their way and see if that does anything different, but it's not really seeming to be very fruitful.
Okay, so what was the actual question? What's the highest p-value you see when removing only one group? So the highest one that I saw was 0.448.
That works for me. Yeah, I don't know. I'm gonna have to look back and see if there's a different way to maybe do it quicker. I don't know.
I don't know. And then now we have to go back to all 6 because it wants the minimum variance and largest variance. So to do that, we need the descriptive statistics in order to see with all 6. So I guess I get to go back and do it again.
Yeah, I did what they told me, and it doesn't even make sense. Like the minimum and maximum. 'Cause
Oh,
there's so
no?
many different. There's like 20 different things to look at, so it doesn't even. I don't know if I missed a step or something, but
Okay, let me see. Recode, do the graph, histogram, footwear, no, kicking accuracy, footwear, okay. Okay, and then did the recoding, then we'll analyze descriptive statistics, explore, kicking accuracy, footwear's the factor, plots. I'm so worried right now that I'm going to blank out on the quiz.
oh, I know. There's
Oh my gosh,
there's
it's
so much. This is throwing a wrench to remembering anything.
so much information. It didn't do it. Why didn't it do it? Analyze. Descriptive statistics. Oh, they're there. They're just processing.
Hmm.
Okay, there's our QQ plots. Okay, and then okay, then the ANOVA test. So kicking accuracy, footwear recode. That's not what I meant to do. Yeah. Options, descriptive, and mean spot. Okay. Okay, let me look at the output and see if I see anything that makes sense on what they're asking.
Okay.
Variances. All right, so the variance for A is 27.358. B is 29.484. C is 27 point, I guess I need to write these down. Once I go past it, I'm not going to remember it. C is 27.208. Go back up. B is 29.484. A is 27.358. D is 53.158. That one's pretty high. E is 31.011. And then stocks is 40.724. Okay, so the question is, when all 6 samples are used, what is the minimum, the smallest variance? So the smallest variance is group C, 27.208. That doesn't make sense though, because it's, well, I don't know. I don't know. You just want to plug it in and see how we do, or what? Or you want to?
No, that works for me. For some reason, I don't know why mine's not doing what I want it to. Because like it worked fine when I was just following along what the guy would have me do, but right now
Mine
it's
did too, but I don't even know if we're doing. I don't even know if we're looking at the right thing on this one, to be honest.
right.
Because this is not at all what they taught us in the lesson. When all
Yeah,
6 samples are used, what's the maximum variance? So the largest variance was 53.158.
that works.
The test for equal variances is satisfied for these data.
Test for equal variances.
Oh my gosh, really? Really?
What's the
Really
test for equal variances?
don't know what I'm doing. Where is the...
Oh, I think that's the rule where if the largest variance is less than or equal to 4 times the smallest variance, then we will conclude that the variances are equal. So
So 53.158 is definitely less than 4 times 27.208. Is that what you're
right,
saying?
yeah.
Look at the checking requirement.
What'd you put for 11? Sorry, I
11.
didn't.
It's okay. 27.208. And then 53.158 for 12.
Yeah, got that one.
And that's based on the variance for that group on SPSS.
Right.
That's the best I could figure was what they were asking.
That's better than my bet. I don't even know what my SPSS is saying to me right now.
And the I don't see on the ANOVA test. Let me go back down to it. It has, for descriptives, it has the n, the mean, the standard deviation, standard error, low bound and upper bound for the confidence intervals, and then minimum and maximum numbers. But I don't think that tells us. I don't think that's what we're looking for. So, okay. So we'll put true. The test for equal variances is satisfied.
Yeah. I think it sounds right to me.
All right, and then construct a QQ plot for each of the 6 samples. So I did that when I did the data I just pulled. Each of the samples are approximately normal based on what you see in the QQ plot. And you said you have those pulled or you don't?
I have, let me see. I have a QQ plot, but I'm not so sure. Now I'm kind of doubting if anything's right, you know.
Okay, let me look and see. Socks looks pretty normal. And they're all just kind of, they're mostly around the line. They have some outliers. B doesn't look very normal. But overall, they look normal. So I don't know if you would say, I guess I'd say they look normal.
That works for me.
I don't know how we're going to do on this one, though, Chase.
Yeah. It's going to be, I'm going to have to go over this like 2 more times.
I guess depending on how our answers are and the actual
Yeah, I
homework
mean,
that we do, it may help it.
yeah, we could be getting it all right, but I'm a little nervous.
The test statistic for an ANOVA hypothesis test is an F statistic. If the is the p-value the area to the right or left? To the right,
Yeah.
because it said we always do the area to the right and not the left because it can't be negative.
Right.
You ready to submit?
No, because we still got to do 7.
Oh, yeah, we
right?
do. Yeah.
I think it's 4. I think you're right.
It's equivalent
But
to conducting independent 2 sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, and 2, 3. So if we have 4 samples, we would have 1, 2, 1, 3, 2, 3, 3.
wait. It would be 1. Yeah, you're right. 1, 2, and then a 1, 3, then a 1, 4, right? If there's 4 of them.
Yes, and a 1, 4. So, and a 3,
And then
4.
a 2, and a
And
2, 4.
a 2, 4. So it's
6.
6. Right? Look at it and make sure that we didn't repeat anything.
Okay.
1, 2, 1,
Okay.
3, 1, 4, 2, 3, 2, 4, and 3, 4. I think that's right. So I think it's 6.
Okay.
You think so?
Yeah. Yeah, I think you're right.
Okay, so let's do 6.
Okay.
Oh, we answered everything. Are we sure? We need any little point we can get this
I
time.
don't know.
All right, let's
All
submit.
right. I don't even want to look at this one.
Hey!
Oh my gosh. I don't know how that happened.
Okay, well, now I feel more confident in how we did it. It's just more tedious.
Yeah, I'm gonna have to go back and work on my SPS stuff.
Well, as long as it works for you when we're actually doing the test.
Yeah, for sure.
Okay. Well,
Alrighty.
I'm going to do my homework for this lesson right now, at least the
It's
first
okay.
go round. So if you get stuck or anything, just let me know and I'll try to help you.
All right, sounds good.
All right, have a good night.
Yeah, you too. I'll post this. I actually recorded it this time, so.
Awesome. Thank you.
You're welcome.
Bye.
See ya.